Alright, class. Here's review number 2. Gonna get a quiz on it tomorrow. Hopefully you're watching it. And even if you're watching it the day of the quiz, good luck today. This is gonna help you a lot. So, this is some stuff that you need to memorize. You absolutely have to have this memorized for the Regents exam. First off, yeah, memorization stinks. But second, it's an easy way to get grades without having to figure stuff out, right? So I call them free questions. As long as you watch this video and you really make sense of this stuff, I've got free answers for you for tests and especially the Regents exam. So let's get into it. So it's about astronomy, deep astronomy. So information that you have to know about the Big Bang. First off, it formed the universe, right? So we formed the universe from the Big Bang. After that, it occurred 13.8 billion years ago, so a long time ago. We are fairly certain about that number. Well, science is fairly certain about that number. It's really good, really accurate stuff. The universe is 3 times older than the Earth. The Earth is 4.6 billion years old. You multiply 4.6 times 3 times older, you get exactly 13.8 billion years old. This is not in the reference table. It has to be memorized. The Earth's age, 4.6 billion years ago, or 4,600 million, that's in the reference table. So, the final thing that you really have to memorize about the Big Bang is the proof of the Big Bang, evidence of the Big Bang. How do we know the Big Bang actually happened? And that's in the form of cosmic background radiation, evidence or proof of the Big Bang. We usually hit this on the Regents almost every single year. Cosmic background radiation. Evidence of the Big Bang is cosmic background radiation. Next, which letter represents the Big Bang? We've got A, B, C, and D. So I look at the timeline, it's in billions of years. I memorized 13.8 billion years. So 13 falls between 10 and 15, right? So 13.8 billion years. The only option is going to be D. But then which letter represents Earth? Well, another number that you should have memorized is 4.6 billion years for Earth. And that's going to be a little bit less than 5. This is present. Letter A is going to be about where the dinosaurs, about where the dinosaurs went extinct. And humans would literally be right next to the present. So if they ask where the earliest humans are, it's going to be right next to present. Just a little bit that we've been around compared to the entire universe. Next, redshift versus blue shift. This is evidence that the universe is expanding. The universe is expanding, and the proof of that is redshift. I like to think of light as being a slinky. So light is a wave, right? So the idea is that if something is coming towards you, the light wave gets compressed and looks blue. But if something is moving away from you and continues to move away, that light gets stretched, and that stretches towards the red spectrum. So they'll ask you questions like, which of these things has proof that the universe is expanding? The answer is always redshift, proof of the expanding universe. If you see the word expanding and universe in a question, it is redshift. The answer is always redshift. We see blue shift only when we see like stars moving towards us, or like Andromeda galaxy, it's moving towards us. We might see some type of blue shift there, but 99.9% of all galaxies are moving away from us and moving away from each other, proving that the universe is growing. It's expanding into nothingness. Awesome. And this is a nice visual. When something moves towards you, the wavelengths get closer together. We see a blue shift. When something's moving away from you, the waves get stretched. It's almost like when you hear a car go past you and goes, right? The pitch gets really compressed, and then it drops low as it moves away from you, getting stretched out. Okay? So you'll often see it as these spectral lines as well. So proof that the universe, what caused the spectral lines to shift from this to this? Well, first off, what I want to show you is that the distance between the standard lines will always stay the same. They'll never stretch out. These lines will never move further apart from each other or closer in. They'll always stay the same distance away. It's like your thumbprint. If I put my thumbprint here, the print's always gonna look the same than when I go over here. So the same thing happens here. We just shift it over towards the red, infrared, or towards the violet if it's moving towards it. So away is going to be towards the red, and that's proof of the expanding universe. So this question, describe how this image provides evidence that the universe is expanding. The spectral lines spectral lines are shifted towards the red from this distant star. Okay, here's some actual Regents questions. Scientists have inferred that that the Earth's original atmosphere was, oh, no, skip this one. Don't worry about this. Boom. Sorry, forget about it. Next, nuclear fusion. Forget that ever happened. Nuclear fusion. So, this is what happens inside of stars. Stars emit light because of nuclear fusion. If you see the word energy and star in an Earth Science Regents question, the answer 99.9% of the time is nuclear fusion. Nuclear fusion just means that we take light elements and we squeeze them together under intense heat and pressure inside of stars to make one heavier element. So we combine light elements to make heavier elements. That is nuclear fusion. Okay, so here's a real Regents question. Identify the nuclear process that uses up stars' core hydrogen and produces the energy released by stars in globular clusters. I see stars, I see energy, boop, nuclear fusion. Or just fusion. Fusion alone is fine. We'll take that. So nuclear fusion, we take small elements and we combine them to make large elements. So this is something they've been saying more recent on the Regents exam. We take light elements to combine them to make heavy elements within a star. This is nuclear fusion. That is the process which creates energy inside of a star. So, the sun and billions of stars revolve around the center of the what? This is the only galaxy you need to memorize for the Earth Science Regents exam, and that is the Milky Way. By the way, it's a spiral galaxy. Looks like that. There's a giant black hole in the center of it, keeping everything together, holding all these edges in, and it actually spirals around itself. I don't know which way it goes, but that's what happens. So final thing, this is a critical thinking process. Let's say they give you the orbital speeds of these different planets, and they give you the distance from the sun. They're asking you if you were located on an asteroid, within the asteroid belt, what is a possible velocity that you could be traveling at? So, if you haven't memorized, we have our terrestrial planets, the first 4, and then we've got our Jovian planets, the next 4. There's Pluto, forget about it. It's a dwarf planet. We don't care about it in Earth science. So, in reality, the asteroid belt falls between the Jovian planets and the terrestrial planets, somewhere between here. Let's say it's right in the middle. How fast do you think you might be going? You could be going 20 kilometers per second. You could be going about 15 kilometers per second. I'll take anything in that range. I'll even take up to 22 kilometers per second, as long as you're between Mars and Jupiter. All right, that's the review, guys. Next, we're going to be doing stars.